Welcome to webinar about D1 push service integration. We hope it will be informative and it will cover all the necessary aspects so you could start your development and integrate the D1 SDK. D1 push prerequisites. Issuer app configuration. The issuer needs to go through the onboarding procedure with the backend integrator. The slide lists on the right side basic D1 service configuration parameters, which will be shared by the backend integrator in the so-called onboarding form. These parameters define the backend environment that will be used by the SDK. For a typical project, we will configure a pre-prod, aka staging, and a prod environment for each customer. Usually, the SDK integration team also shares configuration values to connect to a testing environment, which is called sandbox. Furthermore, the issuers need to pass the onboarding with particular wallet providers and obtain additional configuration parameters from them. More on that in the next slide. The left side shows how the configuration parameters are meant to be applied by the mobile app. The second step shows that the app needs to store them. This is typically done at build time by means of assets or directly hard coding them in the source code as constants. When the application starts, it needs to identify the consumer as it will have to provide its ID in configuration, and to perform login as seen previously. Next, the app needs to create a D1 task instance with the D1 service configuration parameters. D1 task is the main entry point to consume D1 SDK services. After setting up the D1 task, the application has to call the D1 task.configure API to initialize the SDK. Depending on the scope of services, the application is required to provide particular configuration parameters. For example, for D1 push service, the bare minimum is consumer ID and the wallet type. If the initialization succeeds, the app will receive the onSuccess callback, and thus it will be ready to trigger particular use cases. D1 push onboarding for wallets. Before using D1 push service, the mobile developers should go through wallet onboarding with particular wallet providers. In this slide, we are summarizing the key steps for all supported wallets. For Apple Pay, please contact the Apple support via apple-pay-provisioning@apple.com to request entitlement and application whitelisting. Next, you must configure the entitlement in your own application project. For Google Pay, please follow the guide describing the way to gain access to Push Provisioning API and the launch process in general. Specifically, take care about providing the correct application package name and application fingerprint for a particular environment. For Samsung Pay, please follow the Get Started guide and sign up your developer Samsung account at the Samsung Pay Developers Portal. Once you have been granted access, please proceed with registering the application. Eventually, you will obtain a service ID which you will need to configure to the D1 SDK prior to using the D1 Push API targeting Samsung Pay Wallet. You can find additional details and hints in the respective D1 Developer Portal section. D1 Push Flows. D1 Push Provisioning and Digital Card Lifecycle Management. D1 Push service offers three major use cases. These are push, view and control. Push as the primary use case allows the banks to provision digital cards directly to the wallet without a need to ask the user to fill their card details. Additionally, D1 SDK provides APIs allowing our clients to develop user experiences to view and control the created digital cards. D1 Push, Google Pay Push Provisioning Flow. Let's walk through the push provisioning flow for Google Pay as an example. The flow is expected to be started in the issuer's app by showing an Add to Google Pay button for the eligible card, or show a list of all eligible cards the issuer could offer as in second screenshot. Once a user clicks the button or confirms the card selection, the Google Pay wallet comes to the foreground to show a confirmation about which card is about to be added. Next, the user is presented with Google's, and subsequently issuer's terms of service and asked for explicit consent. The flow continues with Google Pay wallet showing progress about the card data processing with the TSP and bank. In case of success, it transitions to the result screen saying, "Card added to wallet and is ready to tap to pay." The user can further navigate to the card detail view inside the wallet as seen on the screenshot number 9. When the user closes the Google Pay wallet and returns to the issuer app, it should display that the respective card has been already added to Google Pay. Check card digitization state in OEM wallets. Now let's have a look on how the user experience could be achieved while using the D1 SDK API. First, we've seen that the app needs to have a mean to manage visibility of a button like Add to Google Pay, Add to Apple Pay and Add to Samsung Pay. For that purpose, the D1 SDK offers Get Card Digitization State API. When the application calls this API with a particular card ID, the D1 SDK evaluates internally and in cooperation with the D1 platform the card state in the wallet. The SDK returns one of the following states: digitized, not digitized, digitization in progress or pending IDV. The digitized or not digitized states are self-explanatory, and the app is meant to either hide or show the Add to Wallet button respectively. The digitization in progress means that the process has been started but hasn't been finished in the wallet yet. The pending identification and verification short IDV state could be reported in case that user initiated the card digitization manually from the wallet, but has not completed the IDV for the particular card. If the issuer supports in-app authentication, it could trigger that flow in this case. We will review the in-app authentication flow later in this presentation. Push to OEM wallets. The D1 SDK provides Add Digital Card to OEM API, which is meant to be triggered when the end user clicks Add to Wallet button for the particular card. The D1 SDK sends a request to initiate the push provisioning for the particular card to the D1 backend. The D1 backend retrieves consumer information from the issuer backend and prepares a push provisioning payload for the particular TSP. All this information is then returned bundled to the D1 SDK. The flow continues when the SDK passes the payload to the wallet application. At this step, the wallet app goes to the foreground and asks the user's confirmation about adding the particular card as we've seen previously. When the user accepts terms of service, the wallet sends a tokenization request through wallet server to the TSP. The D1 SDK indicates the result of the push provisioning attempt in either the on error or the on success callback. For Google Pay, the issuer application needs to implement the on activity result method to receive the push provisioning request result. The application is only meant to pass the received result code, request code and data to the D1 SDK by means of the handle card result method. The SDK will then interpret the result and trigger a respective callback method. Optional use cases. In the next section we will talk about optional use cases, which the issuer app may opt to integrate. Those are, in-app authentication, push to schemes and click to pay, view and control, and Apple Wallet extension. In-app authentication flow. To utilize the D1 SDK in-app authentication functionality, we are presenting the visual flows first, before diving into the details. We will be reviewing here the flow of the Google Pay wallet as an example, but the actual flow for Samsung Pay or Apple Pay wallets is very similar. On the very left you can see the wallet UI prompting the user to add various types of cards to the wallet. For our use case, the payment card option is of relevance. The user can enter card details manually, or can use optical character recognition short OCR feature built in the Google Pay wallet to capture the digits and expiry date of the physical card. Next, the user is guided through the terms of service agreements. In case of OCR, or manual card entry, the user will be prompted to pass verification as a next step after accepting terms of service. Here at step 5, the users can choose their preferred method of verification. In-app authentication is described here as sign in to the bank app. When selected, the Google Wallet is forwarding the user to the issuer application to prompt login. Login is considered positive authentication for the purposes of D1, and as you can see at screen 7, some form of UI inside the app should guide the users to activate their card. It is important to know that in-app authentication relies on the digital card ID being provided from the wallet via the intent to the issuer application. The issuer application is then expected to pass the digital card ID to the D1 SDK at the point of card activation call. In-app authentication, TSP configuration. This slide presents the additional parameters that need to be configured in the TSP in order to support in-app authentication for particular wallets. In the TSP Customer Configuration portal, you should have already added parameters in the section named In-app Provisioning to support the actual push provisioning, which has been described earlier. Please note that the TSP configuration is organized per token requester, which corresponds to a particular wallet. The following parameters are meant to be provided in a dedicated section, that is usually named In-app Authentication. For Apple Pay Wallet, these include Application Launch URL, Associated Store Identifier, and Associated Application Identifiers. For Google Pay Wallet, these include Application Package Name, and a fully qualified action, which will be used in the intent to launch the issuer application. In-app authentication, card activation by D1 SDK API. Now let's have a look on a detailed sequence of steps corresponding to the in-app authentication flow that we reviewed earlier. To support this flow with D1, we would like to remind you that the issuer must have registered the consumer and cards with a server call to the D1 backend as explained in the prerequisite section. The process begins with the wallet application calling the issuer app with extra information in point 1. In the case of Android, the extra information is passed as intents extra and contains most importantly the digital card ID. For iOS, a serial number gets submitted by the Apple Pay wallet. The issuer application is required to use the extra information to identify and display the user's card for which the verification was requested by the wallet. The next important phase is the authentication to the issuer app, which is detailed in steps 4 to 10. Once issuer app has authenticated the end user, it should request the digital card activation. This is done by calling Activate Digital Card and supplying the digital card ID as a parameter. The SDK then builds and sends the activation request to the D1 backend, which forwards it further to the TSP. The TSP is in charge of activating the card in the wallet itself. Success or failure result is communicated back to the issuer app by means of the SDK's callback API. The issuer app is recommended to redirect the user back to the wallet app at the end of the flow. Push to schemes. Get token requester list. Digital cards can be also pushed via the D1 SDK to other token requesters supported by TSPs, such as Netflix or Amazon. This feature is typically visualized to the user as an Add to button for a particular card. To start the process, the app will first need to call the SDK API Get Token Requester List and supply a card ID. The SDK will get the list of eligible token requesters from the TSP as shown in step number 2. Next, the D1 SDK will contact the D1 backend to get the metadata associated for each token requester in the third point. Lastly, the SDK notifies the issuer app by means of callback on success method with the list of token requester objects. Each of those has an associated ID, name, as well as provisioning methods. The issuer app is meant to use this list to populate the user interface, allowing the end user to choose the token requester. Please note that the token requester logo is not provided by the D1 solution and the issuer application needs to source it from elsewhere. Push to schemes, provisioning. Following the process, we are now in the provisioning step when pushing to schemes. This step starts when a user selects the target token requester for the push provisioning. At this point, the issuer app is meant to call Add Digital Card to Scheme API, while providing additional data such as card ID, token requester object, an app callback URL, and terms and conditions acceptance flag. Next, the D1 SDK will contact D1 backend to get the provisioning information from the TSP. Then the SDK will call on success callback method, and it will provide a token requester push URI. This URI could be either website URL or an application deep link depending on the token requester's implementation. If the push URI is a website, the application has to support a web view in order to manage it properly. When the token requester's app or website is presented, the end user experience is mostly dependent on the token requester's implementation of the process. Once the token requester completes the card tokenization, it sends the end user back to the issuer's app via the app callback URL provided by the issuer application at the point of the API call. List digital cards. The D1 SDK offers a feature for listing digital cards that have been created from a particular funding card. To achieve that, the issuer app could invoke getDigitalCardList API method and provide a card ID. The SDK will communicate to the D1 backend, which will further call the respective TSP to retrieve the list of digital cards in third point. Lastly, the SDK will return the list of digital cards to the issuer app in the onSuccess callback. The issuer app is meant to use this list to populate the user interface, allowing the end user to view the state of each digital card. Please note that the token requester logo is not provided by the D1 solution and the issuer application needs to source it from elsewhere. Control digital cards. Digital cards can be controlled via the D1 SDK. The issuer app could trigger an action depending on the initial digital card state and user's decision. The Update Digital Card method supports the following card actions: resume, suspend, and delete. The SDK communicates the digital card state update request to the D1 backend, which will then forward the request to the respective TSP. Lastly, the SDK notifies of the state change in the onSuccess callback under number 4, which the issuer application should observe to show a user notification or to perform a user interface update. Apple Wallet extension. An app extension iOS feature lets you extend custom functionality and content beyond your app and makes it available to users while they're interacting with other apps or the system. The main purpose of implementing an Apple Pay Wallet app extension is to provide a seamless card provisioning user experience. The picture on this slide describes the basic life cycle of an app extension in general. The process involves users selecting an app extension, which prompts the system to activate the chosen extension. Once activated, the extension's code will be executed to perform its designated function. Finally, when no longer needed, the system terminates the app extension. User experience for Apple Wallet extension. By provisioning cards within the Apple Wallet application, it enhances the in-app experience, saving the end users from having to go through the process of manually entering their payment card details. The picture in this slide illustrates each step of the user experience when an Apple Wallet extension is invoked. First, the end user selects the option to add cards into the wallet. Behind the scene, Apple Wallet checks with the issuer application for the availability of the cards. If the cards are available, the Apple Wallet application will show the issuer application in the list. When the end user selects the issuer application, the issuer will request an end user authentication. The last screen on this slide shows the authentication being performed by the issuer application. After successful authentication, Apple Wallet gets from the issuer application the available cards and displays them. The end user could then select the cards to be added to Apple Wallet. Then, for each card, the end user is able to review the card details and confirm the terms and conditions. Finally, for each card that has been selected, Apple Wallet will request for the provisioning payload from the issuer application, and it will proceed with the provisioning flow itself. Apple Wallet extension configuration. The Apple Wallet extension requires two extensions from the issuer application: non-UI and UI extension. The D1 SDK provides the base class implementation for the non-UI extension, such that the application developer does not need to perform any major implementation. This is possible when the app developer configures the wallet extension config during the application launch. Even though this configuration is required only once after the application is installed, it is recommended to call it on every application launch to update the latest cards. Additionally, the issuer app should call a login extension method of the D1 SDK after the end user authentication in the UI extension, so that the SDK can continue with the next steps in the non-UI extension. Testing and troubleshooting. Testing the D1 SDK use cases. The D1 SDK is available in two variants: debug and release. You can use the debug version for testing and troubleshooting. It gives you the opportunity to observe local logs in console or secure log. It ignores certain security violations too. The release version is intended only for production deployment and provides only secure log. All security protections are applied here. The D1 SDK deploys several runtime application self-protection mechanisms. It prevents running its use cases when the application executes on an emulator or on a rooted device. In the release version, it also detects if there is a debugger attached. Next, it checks if a sensitive method was hooked, or if data was tampered with. Last but not least, it verifies that server certificates are part of a trusted certificate chain when communicating with back-end components. To avoid any trouble during your testing, please follow these recommendations. Use a physical device that is not rooted, and that has never been rooted before. Make sure that the application has direct connection to the internet and avoid using VPN. Please note that you can use a debugger only with the Debug SDK variant. Environments. On this slide we will present you with a quick overview of our environments, what data they contain and how they interact. This is important information to remember for us to use a common language in our communication and that limitations are known up front. In general, on the left side we have mocked data and on the right-hand side we have real data from the schemes such as MasterCard or Visa. Within those data buckets, we have three different environments which you will interact with during the integration phase. Sandbox on the left in blue contains the D1 sample application which integrates the D1 SDK as well as a mocked backend. The supported D1 services are pay, card display, and tokenization. In practice, this means we will have delivered to you the most current D1 SDK and instructions how to access our sample apps both for Android and iOS. In this fashion, you will be able to start understanding and development of your own SDK integration into your app right away. For the D1 backend side, this also holds true that you can use it right away. To move your development forward into the pre-prod environment, you will have to pass the bi-party testing step. During this process, we will help you with test cases and checks that all the implementation is done correctly against sandbox environment and that you can use the D1 SDK as expected. Once you are connected to the pre-prod environment, meaning you will have changed configuration values on the mobile side, you will be able to use real data from MasterCard or Visa. While this environment does not yet function exactly like a fully live environment, this allows you to use data now stored in the schemes such as agreed bin ranges. Lastly, to actually go live with your integration or to move forward into prod environment, one last testing step has to be passed. We call this tri-party testing as it includes you, your scheme provider or providers and us. The target of this testing period is to be absolutely certain everything is implemented and functionally in order before launching the product publicly. As you might have noticed, we are also describing an Apple or Google sandbox in black on the right-hand side. These sandbox environments are controlled by these companies directly, and they have no relation to our own sandbox environment, and this distinction is important to avoid future confusion. If you have opted to implement the D1 push service, then this will be of importance to you as this is where and how you can test your implementation. In the next slide we will go into further detail of which environments have which data associated as well as the limitations which exists around D1 push testing depending on MasterCard or Visa. Test environments. As previously mentioned, this overview shows you the data used on our different environments and how they interact with Apple Sandbox and Google Sandbox. Everything which is blue here can be considered a test environment. Black represents the live production environments. Also, I would like to focus your attention on everything in red. This is what issuers or developers have to take care of. It is especially important for anything related to D1 push, where Apple Pay, Google Pay, and Samsung Pay have different requirements. Lastly, in the case of Apple Pay with the Visa combination, it is unfortunately not possible to test when you are connected to our pre-prod environment. MasterCard has their own dedicated member test facility, or MTF for short, which allows for some testing, but this is not the case for Visa. With Visa, you will have to progress all the way to prod environment with us, and then you can set up test cards and whitelist your test devices. You could pause the video here for a short moment and study the slide or come back to it later for reference. Troubleshooting, issue reporting. We would like to encourage you to review the troubleshooting section and FAQ section first, before submitting an issue report. Should you not be able to resolve the issue by yourself, we would like to ask you to provide your report in the following format. 1. Describe the use case which causes you the problem, for example, SDK login. 2. Describe your expected result or behavior. In this manner, we are able to point out expected design behavior and ways how to implement the solution. 3. Describe your actual result or error in as much detail as possible, including example error codes and messages. Troubleshooting, contextual data. When requesting support from the integration team, we would like you to provide relevant contextual data for the affected use case. This means the relevant timestamp, and specific identifiers such as issuer ID, consumer ID, card ID, etc. These would allow us to speed up the process of searching our D1 backend logs. Further, we would need to use specific data such as JWT in case of login, as we have experienced frequently an issue with the JWT being invalid. Lastly, for D1 push-specific issues we need to know if Apple Pay, Google Pay, or Samsung Pay is being targeted as well as wallet-specific configurations such as Visa Client App ID or Samsung Service ID if applicable. Troubleshooting, obtaining device logs. There are two main ways to obtain logs for the D1 SDK. 1. Debug logs. 2. Secure logs. Debug logs are used for troubleshooting during the D1 SDK integration process. It is the direct output to the console for iOS or Logcar for Android. This output will only be available for the Debug SDK variant. Secure logs should be used once your application has gone live in the field. These logs are encrypted and can be read only by the integration team. When enabled, the SDK automatically creates and rotates the log files within the device file system. You will then have to extract those files and send them to the integration team for investigation. The level of log details is configurable by your application. Please refer to the developer portal for detailed instructions on logging. Next steps. Thank you very much for attending this D1 SDK workshop webinar. We hope we answered most of your questions, and you found this information helpful. We encourage you to go through our developer portal pages to understand the solution in more detail. The next phases on your D1 solution integration project should be discovery, onboarding, integration, testing, and then launch. You will be guided through this journey by our team of specialists and a project manager. We will do our best to make your integration smooth and trouble-free. Thanks for selecting us as your service provider.